Hi everyone, I'm Cheryl. In this problem, we're asked to find the directional derivative of a function at the point 1, 2 that's in the direction of my vector 3/5 I plus 4/5 j. Now, one way you can think of a directional derivative is if you look at the given vector and you think of a plane in which this vector lies. We're going to take that plane and intersect it with my surface. Now, when we take a surface and intersect it with a plane, we're going to get a curve. And we want to find the slope of the tangent line to that curve at the point 1, 2. All right, well, in order to find a directional derivative, we know that we can get it by taking the partial of f with respect to x and multiplying it by the cosine of theta, adding the partial of f with respect to y, and multiplying it times the sine of theta. Now, what is that cosine and sine of theta? Well, the direction that I need to be looking at is going to be the unit vector cosine theta I plus sine theta j. Now, that's the definition. So to apply this to our problem, we're going to be able to get the first partials. That's not an issue. But we need to consider what cosine theta and sine theta are. Now, I was told what direction I was supposed to look at by that vector v. But what I don't know is I'm not sure that that's a unit vector. So let's go ahead and verify that. So we're going to find the norm of my vector v. Okay, so the norm, I'll take the square root of the component squared. So that's 3/5 squared plus 4/5 squared, which is the square root of 9/25 plus 16/25, or the square root of 25 over 25, which is the square root of 1, or 1. So it just so happens that the vector that was given to us was the unit vector. So I can think of this as being written as v equals the cosine of theta times I plus the sine of theta times j. So in other words, 3/5 is cosine theta and 4/5 is the sine of theta. So now I can apply this to my definition. So remember, the first thing we need is the partial with respect to x. So I'll treat y as if it's a constant. So my derivative is going to be 3 minus 4y plus 0. And then the cosine of theta, I know, is 3/5. I'll then add that to the partial with respect to y. Again, I'm going to treat x like it's a constant. So the first part will be, the derivative will be 0. If x is treated as a constant, that will be a minus 4x for the derivative and plus 9. And the sine of theta is 4/5. So that gives me 9/5 minus 12/5 y minus 16/5 x plus 36/5. Or in other words, 45/5 when I combine my constants, which is just a 9, minus 12/5 y minus 16/5 x. Now this gives me the directional derivative at any point. I'm interested in what's happening at the point 1, 2. So my directional derivative at the point 1, 2 is going to be 9 minus 12/5 times 2 minus 16/5 times 1, or 9 minus 24/5 minus 16/5, which is going to be 9 minus, that'll be 40/5, which is 8. And so my directional derivative is 1. I hope that was helpful. Thanks.